Hello, welcome back. In this video, we'll discuss what is the name of the Grignard's reagent and the carbonyl compound which on treatment with each other gives an adduct, which on further hydrolysis gives a type of alcohol which is already given on the screen. You see, this is the alcohol prepared from a Grignard's reagent and carbonyl compound. We have to find the carbonyl compound and the Grignard's reagent. For your information, this H is from water during hydrolysis. This part is the carbonyl compound, and this part is definitely the alkyl group attached to the Grignard's reagent. So I'll write the Grignard's reagent. I'll write the carbonyl compound first. You see, this is CH2O, CH2O, but C is bonded to O. As oxygen can form two bonds, so a double bond will be there, and two H atoms are there, so this can be written like this. So this is CH2O, and the Grignard's reagent is MgX, but the R group is this part, cyclohexyl. Let us find the product, whether we are getting this compound or not. You see, this O is electronegative and this carbon is electropositive. This part in Grignard's reagent is electronegative and Mg is electropositive and X is electronegative. So this part will attack this carbon of the carbonyl group, and the bond between C and O is shifted, particularly this pi bond is shifted, and this MgX group will be bonded to this O. Now we'll get the product, or you can say an adduct, H, C, H. At the bottom you will find that cyclohexyl group, then double bond becomes single bond O, and O is bonded to MgX. This one on hydrolysis with water in acidic condition gives the above alcohol. You see, water can be written like this, HOH. This H is bonded to this O, and this bond breaks, and the OH part is bonded to the Mg. So the product will be, you see, this group is already written over here, then C, this C, and these two H atoms are over here, CH2. Then a single bond is there. You see, this is a single bond. Then O, yes, this O, and the H is bonded to O. You see this H. So the starting Grignard's reagent is cyclohexyl magnesium halide, and the carbonyl compound is formaldehyde. This is formaldehyde, and this is cyclohexyl magnesium halide.
Let us do another question. When a carbonyl compound is treated with a Grignard's reagent, an alcohol is produced, and the
alcohol is, yes, this is the alcohol produced by the reaction of a Grignard's reagent with a carbonyl compound. For your information, this H is from water during hydrolysis. and this CH2O is from a carbonyl compound. And this part is definitely the alkyl group of magnesium halide. So we can write the carbon compound at the bottom. You see this C is written and there is one O over here. Between C and O you will find a double bond, and this C is connected to two hydrogen atoms, so definitely two H atoms will be written like this. So this is formaldehyde. Now this compound is treated with a Grignard reagent, and the Grignard reagent is RMGX, that you know, alkyl magnesium halide, but the R part is the isopropyl group. You see this is MgX, X can be chlorine, bromine or iodine, and Mg is bonded to this CH, then CH is bonded to two CH3 groups. Now we have to show the reaction whether from these two compounds can we prepare the above alcohol. Let us start the reaction again in a reverse way. When this Grignard reagent is treated with this carbonyl compound, the R part attacks the carbon of the carbonyl. Why? Because this part is negatively charged. Why? Because this Mg is electropositive. As it is electropositive, this carbon is electronegative, and this X is also electronegative. In case of carbonyl, O is negative, electronegative, and C is electropositive, so carbon gains partial positive charge, and this isopropyl group attacks this CO. This isopropyl group attacks the C of CO, and the double bond becomes a single bond, or you can say the pi bond is shifted, and this O is attacked by this MgX. Then the adduct will be H C H O MgX, and C is bonded to CH, this CH, and this CH3. This is the adduct formed during the addition reaction. This adduct on hydrolysis gives the said alcohol. You see, during hydrolysis you will give water in acidic condition. This O is bonded to H, and OH is bonded to MgX, and the product is used CH3 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 CH3. Then this part CH2, yes, it is written over here. Then O, this O is written over here, and O is bonded to this H, and this is written over here. So we are able to find the starting carbonyl compound and the Grignard reagent used in the process. Let us do a general reaction. Suppose during addition of Grignard reagent to a carbonyl compound, an alcohol is produced as shown on the screen: RC, R prime, R double prime, OH. We have to find the starting carbonyl compound and the Grignard reagent. For information, this H is from water during hydrolysis. between C and O you will find a single bond. So CO is there, but C is connected to two alkyl groups, either R double prime R, or you can say R prime R, or you can say R prime R double prime. So you can take R double prime R, or you can take other two alkyl groups, or you can take R prime, or R prime R double prime. But between C and O in carbonyl compound you will find a double bond, so obviously a double bond is there. You see, you have taken R double prime and R in the carbonyl group. So this group is present in the Grignard's agent MgX, and this R prime is written over here. This is alkyl magnesium halide. If you would have taken R prime over here, then this could have written over here. So no need of thinking about all this. Okay, you see CO is bonded to R double prime and R, and Grignard's agent is, let us add these two compounds. This R prime will be bonded to this carbon because it is electropositive, and this R prime is electronegative, and this pi bond is shifted and O becomes negative. MgX will be bonded to this O, and an adduct will be formed over here. You see, C single bond O MgX, and C is bonded to R double prime and R. Then this R prime is written at the bottom. Then this on hydrolysis HOH, H is bonded to this O, this OH is bonded to, so you'll get an alcohol as shown in the screen. You see, this R group is there, okay, this C is there over, and this R double prime is here, and this R prime is also over here. So you are going to get an alcohol as already written on the screen.
If the alcohol produced during the reaction of Grignard's agent and carbonyl compound is OH, then what is the name of the starting carbonyl compound and Grignard's agent? You know,
this H is from water during hydrolysis of the adduct, and this CO is in the carbonyl compound. Obviously this H will be along with this carbon because H cannot be a part of Grignard's agent. H cannot be a part of Grignard's agent, so H should be along with this CO group, that is COH, and between C and O you will find a double bond. Very simple, because carbon compound is C double bond O, and carbon has 4 bonds, 1, 2, 3. Another bond is there. This might be CS3 or C6H5. If it is C6H5, then CS3 is in Grignard's reagent, or you can write the Grignard's reagent as MgX, and this R part is CS3. Then if you add, you will get an adduct, which on hydrolysis will give the above product. If you want to write C6H5 over here, then you have to write CS3 over here. You see, the carbon compound can be written as HC double bond O CS3, and the Grignard's reagent will be C6H5 MgX, and the adduct formed on hydrolysis gives this alcohol written on the screen. Let me write the product again for your clear understanding. This C6H5 will be attacking this carbon, and this pi bond is shifted, MgX will attack over here, so you will be getting HCCH3 and C6H5 will be over here. Then C double bond O becomes single bond, then O is bonded to MgX, which on hydrolysis HOH in presence of acid, this H will attack over here and this OH will attack with Mg, and you will be getting HCCH3 C6H5 OH plus Mg OHX. And you can try this one. Thank you.